We're now ready to start the Cellguard hardware commissioning process. Connect a USB cable or RS-232 cable from your PC to the Base Coordinator Unit, BCU. Next, power up the BCU by using the power cable coming from the VTC. If you do not have a VTC or do not have power from the VTC, use the BCU's external power supply. The power LED should be green, indicating the BCU is on. Open the Cellguard Wizard program by going to My Computer, and then go to the C drive or the drive where you installed Wizard. Open the Wizard folder and double-click on the wizard.jar executable file to open the Wizard interface. Select the Commission Hardware button and click Next. Now, test the connection from the BCU to your PC. If you get a BCU connection error, reset power to the BCU and try again. After a successful connection is established, click Next. On this screen, the Cellguard System date, time, and the measurement interval time is set. The Wizard will populate the date, time, and time zone from the PC you are using for commissioning. If you are not set for the correct date and time, or you are in a different time zone, change it to the correct settings. Midtronics recommends that you use the default measurement interval times of voltage and temperature every 4 hours and conductance every 7 days. If altered, these settings may impact system performance. Once set, click Next. Here, the frequency channel and private area network ID for the BCU will be set. The Wizard uses a random number generator to assign these values. Midtronics recommends that you use the values generated by the Wizard. Once the values are set, click Assign. When you see BCU assignment successful, click Next. Now, enter the number of sensors for the battery string you are commissioning. For our demonstration, 4 will be used. Once entered, click Next. Next, select the battery model for your installation. Scroll through the list and select the battery model being used. If your battery model is not listed, pick a model that is the same voltage and similar in amp-hour capacity for now. Later, you can change to the correct battery model in the CellTrack software. For our demonstration, we are going to select C&D UPS 12-140FR. Once selected, click Next. This screen provides information on some general precautions that should be taken when working on battery systems. Read these over and follow what is applicable for the installation. Remember, you should always follow your company's safety policies. Click Next. The Wizard makes a grid for the number of sensors you entered. If 40 sensors were entered, then the Wizard would have made a grid consisting of 40 squares on this screen. Since 4 was entered, the Wizard made a grid of 4 squares that represents the 4 sensors we are commissioning. Start by connecting the first sensor to the cable set coming off of battery number 1. For consistency, Midtronics recommends that the most positive battery in the string is battery number 1. The LEDs on the sensor will go through their power-up sequence of red, red, yellow, yellow, green, green. Wait until the status LED is in a continuous flashing green state. Now click Test Sensor. The square for sensor 1 will turn blue, indicating the commissioning of that sensor has started. It is important to connect only one sensor at a time to avoid getting an error message. When the first sensor is commissioned, the square will turn from blue to green, and you can connect the next sensor. Now that the square has turned green, connect the next sensor to battery 2. The LEDs for sensor 2 will go through their power-up sequence. Wait until the status LED is in the continuous flashing green state, and then click Test Sensor. The square for sensor 2 will turn blue. Wait for the square for sensor 2 to turn green, and then connect the sensor for battery 3. Wait for the LEDs to go through their power-up sequence, and click Test Sensor. Again, the square turns blue. Wait for the square for sensor 3 to turn green, and then connect the sensor for battery 4. Wait for the LEDs to go through their power-up sequence. When ready, click Test Sensor to commission sensor 4. The square for sensor 4 is now blue. Wait for the square for sensor 4 to turn green. When the square for sensor 4 turns green, you can power up the VTC. And wait for all the sensors to finish their conductance testing. As you can see, the sensor numbers for 1, 2, and 3 are black, and number 4 is still white. This indicates number 4 has not finished its conductance testing. Once the last sensor's number goes from white to black, the Assign VTC button will become active, and the VTC can be assigned to the system's private area network. Click on Assign VTC. The wizard is now assigning the VTC to the sensor network. When you see the assigning of the VTC was successful, click the Next button to review the initial battery measurements. The wizard allows you to review the readings from each sensor for the corresponding battery's voltage, conductance, strap resistance in microohms, and temperature in degrees Celsius. If any of the readings are suspect, you can reset the battery by entering in the sensor number and then clicking the Test Sensor button. If all the readings look fine and there is no reason to retest, then click the Next button. At this point, the commissioning of the hardware for the string of 4 batteries is completed. There are 3 options in the wizard to choose from on this screen. If you need to add another string to the same battery plant, so it is a string that is in parallel or on the same bus with the string just commissioned and will share the same BCU, click on Add String. If you need to commission the hardware for a string of batteries that is on a different power plant, and it has its own BCU, then click Add Plant. Or if you are ready to commission the network portion, you can click Commission Network. If you are not ready to do any of these options at this time, click Finish. The wizard will ask you if you are sure you want to close the wizard. Click Yes, and the wizard will shut down. To commission the hardware for another string from the same power plant to the existing BCU, click Add String. A message will pop up asking, "Are you sure you want to add a new string?" Click Yes to proceed. The number of sensors is 4 again. Click Next. This string consists of the same battery model. Click Next. Once again, read over the safety precautions. Click Next. Now, start the same process for commissioning the sensors. To commission the hardware for a new battery plant, click Add Plant. A message will pop up asking, "Are you sure you want to add a new battery plant?" Click Yes to proceed. Disconnect the USB or RS-232 cable from the first BCU. Without closing the wizard, move your PC to the BCU for the new power plant. Connect the USB or RS-232 cable from the PC to the BCU. Either power up the BCU or reset power to the BCU if it is already powered. Now, test the connection. Once it is successful, click Next. Again, start the same process for commissioning the sensors. If you get a pop-up error message, follow the instructions in the pop-up window and retry commissioning the sensor. Be sure to leave the sensor connected to the battery. Hold down the Setup button on the sensor for more than 5 seconds with the LEDs off. Release the button and wait for the LEDs to go through their power-up sequence. When you see the status LED flashing green, click OK, and then click Test Sensor. The square for the problem sensor will go from red to blue, indicating the wizard is trying to commission the sensor again. When the square turns green, the sensor was successfully commissioned, and you can continue with the next sensor. This screen shows the initial readings generated during the commissioning process. The conductance for battery 2 is a little low in comparison to the other batteries. Check the connection from the cable to the battery, and also make sure that the battery hardware is properly torqued. Once this is verified or corrected, enter the sensor number that you want to retest and click Test Sensor. If you are retesting with the existing sensor, click Yes. Once the testing is complete, check the new readings from the sensor. The voltage and conductance at both now are at a value that we would expect to see.